Hello everyone, and thanks for joining me again today for another session of Me Programming Daily. During today's session, I would like to focus on correctly determining widths of various elements of my diagrams. For those who were watching, for the last few sessions, I've been having problems determining the width of a diagram if gamma connections are present. And this led us to refactor the code and to finally get to a dead end with max excess. But now I'm back with the new idea, and that is to reuse this function scout to determine widths of various elements if they are not standard before we start rendering. And I think the idea is feasible. I don't have it fully laid out in my head, but the concept is very appealing. So what I'm planning to do is to capture the width of elements who have an ID, because those are the elements that we'll be leading to with our gamma connection IDs. If an element does not have an ID, it means that no gamma connection leads to it. Therefore, its width should be standard. So once we have this collection of all widths, it should aid us in this method function render or render prime, as we're trying to determine what should be the position, say, of the right-hand side branch, or of various blocks in the diagram. So the way I'm capturing the width of blocks for now is just to slightly re-implement the function width. Yeah, it works very similarly. What I'm going to add to this function, hopefully today, is an extra little bit of width for any connection, gamma connection, that is leading to our block. So let's see how this goes. I started some experimentations during the weekend, and here's what I'm getting: an exception, but that's expected exception. So what happens is we're trying to determine a maximum of an empty list. So let's cater for that scenario today. But before we do, I just need to simplify this a bit. I think this should be much easier if it works. If it doesn't complain about the number of arguments, we should be good. Of course, this will return an exception as well, or throw an exception, but it's fine. Okay, so what are we getting here? We just got 1 and 0, which is not really correct. Let's go with widths. We don't need this. I'm not really expecting the output to change, but at least it will be a little bit cleaner. So 1, 0. Let's see why that is. Oh, because none of them have IDs. All right, all right. So for now, let's just cater for this maybe. So at the end of this exercise, I would like to have a collection of pairs, ID and width for the entire diagram, hopefully altered by gamma connections, so that if my block identified by 1 has, say, width of 9, if a gamma connection leads to it, we append like plus 0.1 to it, depending on how many connections like that we have. If we have 1, we just append 0, 1. If we have 2, 0, 2, and so on and so on. So this should already make a difference. And we need a maybe here. And the reason it's called scout, because it's scouting for widths. Okay. So just to go back to our diagram, we only have one question with an ID, and the right-hand side of it leads back to the beginning question one. So technically, we only have one block with an identifier, and that's the question one here, and that is of width 9. Let's see if that checks out. And everything else is of width 3 except one block of width 6, and I believe this is question 2. Let's see if that's true. Question 2 should have width 6 because this is 3 and this is 3, correct. And question 1, identified by 1, should have width 9, 3, 3, 3, correct. All right, so we're almost home, but this collection is pretty useless to the caller because many of those IDs are just empty. So what we need is to convert the result to a map. So let's just add an ampersand, sorry, not ampersand, a single quote to these. And we'll have another version here that will be working with a map. So the return type of this is going to be map ID and double. So the key is going to be an ID and map, and the value is going to be double. Just use insert. I'm not sure what's the best way to format this. I'm just going to go with my traditional excessive number of tabs or spaces. Okay. So if we're dealing with something that does not have an identifier, we return accumulator. Otherwise, just identifier and width, we return, oh, and here we're not working with maybe, we're working with just an ID. We're adding the following pair to the accumulator, I and width. So at the end of the day, we should have only one element in the widths. The map starts with this, with empty. Oh, of course. So it should be not this, but insert. Oh. Yeah, that looks better. Okay, let's see what the problem is here. Oh. Okay, perfect. So this is good. Now, we know that there's one element that leads back to it. So the width of question 1 should be automatically increased by whatever constant we choose. For now, let's just decide it's going to be 0.1. So for now, we're trying to determine what we previously called max x, meaning what is the maximum amount of space a block with all the connections leading to it can occupy. And just for the sake of an experiment, it works perfect. So now we need a function that iterates through those blocks again. And alters the map of ID and width, giving them new widths based on the connections that lead to those blocks. I'm just like struggling with name, so let's just call it ABC. So it is going to take the map and it's going to return an updated copy of it. And now we just fold. Let's copy the formatting that was suggested here in the scout function. And we only care about forks. Identifier, content, left, right. gamma connection identifier. We return, just for now, accumulator. Otherwise, we would also return accumulator. Or maybe not accumulator. Let's insert. So first of all, we need to look up widths. So that's the width. And let's not start with empty, let's start with widths. That way, if we insert, the last value should be overwritten. Let's make it like a hard-coded constant for now. Oh. Oh, yeah, because this is also maybe. But we have a catch-all here, so that's good. So we just need to add the data constructor. Adjust. So So this is not called yet. It takes the whole screen, but I do believe there is potential in these 4 functions. So instead of calling scout, let's call ABC. Oh, and now we're calling this with empty. So I'm expecting 1 element in the returned map. Let's see. Oh, yeah. That is easy to correct. Oh, let's have it basically call the scout. And then okay, so 2 corrections. 1, we get 2 elements because we are inserting to the existing collection of, or the existing map of widths. That's good. And no, just 1 correction. And the 9.1 is correct. All right, so that is very promising. So let's pretend that our bubble sort, let's see how it looks like. Not only action 7 leads to question 1, but let's pretend that also action 6 leads to 1. Let's see what happens. Action 6 leads to 1, because this is the right-hand side. We can't do that. This is right-hand side, we can do that. Why not? Maybe, yeah, let's lead to 1, and then we'll test 2 here. So if I run this, ID 1 should get 9.2. ID 2 should be unchanged. Okay, that is not what I expected. And let's test 2. That is also not what I expected. Okay. What about 1 here? It still doesn't work. Let's remove this. Oh, this doesn't work. I wonder why. Let's give it an ID. It's 3. We should also technically increase the size of this. But that is okay. For now, we're only dealing with gamma connections, so if we increase the size or the width of parent, automatically that is increasing the size of the, like so to speak, a container in which the children are stored. So let's not worry about that for a minute. But I wonder, why is this not affected? Hmm. If I placed one here, that wouldn't even work, would it? Yes, it wouldn't even parse. Let's remove this. It's just a different body of a fold. Like this. Let's start with empty. Am I ignoring that fork? Just to avoid any confusion. Oh, it's just, not just, it's simply ID. Hmm? So it looks like my parser is wrong. My parser is wrong. Got my connection again. So now we should expect 2 elements in that map. Hmm? We should expect 2 forks, don't we? Should we? 1, 2. I'm starting to doubt myself. Okay, let's see what we have. No, this is looking correct. What am I missing? This is the left-hand side branch. Right-hand side branch. And the ID. Just ID. Let's put that aside. Just ID. Action 6 goes here. And just ID. So the parser is fine, thank goodness. I've forgotten how to use maps. Let's pretend that we're only dealing with a list of tuples. And here Why am I only getting one? It must be something really stupid that I'm just not seeing. Oh. Yes, I am an idiot. All right. What happens is we're not recursively going through these collections of blocks. Therefore, we're only getting start terminator, question, and end. Therefore, one fork. This is why we're ignoring this. Okay, I clearly need a break now. So during next session, we'll be going recursively through this collection of blocks. I started doubting everything. Okay, but I just need a little break. Yeah, we'll go recursively through these collections of blocks, and we'll try to append the right value to the detected widths. So let's bring the map back. Okay, so we get 1, 6, 3. So let's run a quick experiment. This should now be bumped to 9.2, and we should get one new identifier that is of width 6. Identifier 3 of width 6, correct, and 9.2. Yes, perfect. That is working fine. All right, so we have some recursive functions to do during the next session, and then once we're done, I think I will be ready to weave this new map of widths into this function, where we take the width not from the function width, but from the collection of widths from the map. And I think that should nicely determine where the right-hand side branch should be positioned. Yeah, right. Thank you all very much for your attention today and for your patience. That last issue was pretty silly. And I wish you a fantastic day ahead. And yeah, take care of yourselves, and I'll see you next time. Bye.